Hello friends, welcome to my channel Maths Made Simple. This is another video in the series of fractions. Today we will discuss about equivalent fractions, simplification of fractions and comparison between fractions. Let's start with equivalent fractions. Fractions that represent the same value are called equivalent fractions. So if I have a fraction and I multiply the numerator and denominator by the same number, I will get an equivalent fraction. Let's understand through an example. Suppose I have a fraction 1 by 2. I multiply the numerator by 2 and denominator by 2. I will get 2 by 4. So 1 by 2 and 2 by 4 are equivalent fractions. They are same in value. Now again, suppose I multiply the numerator and denominator by 3. So 6 by 12, 2 by 4 and 1 by 2 are equivalent fractions. Again, suppose I have a fraction 4 by 8 and I divide the numerator and denominator by the same number. I will get another fraction which is again equivalent to the original fraction. So 4 by 8 and 2 by 4 are equivalent fraction. Further dividing the numerator and denominator by 2, we get another equivalent fraction. So if I have a fraction and if I multiply the numerator and denominator by a common number, same number, I will get another fraction which is equivalent in the value. Same thing is for division. If I divide the numerator and denominator by the same number, I will get the equivalent fraction. But remember, the number has to be same. If you are multiplying the numerator by a number, you have to multiply the denominator by the same number to get the equivalent fraction or the fraction which has the same value. So if I multiply 4 by 8, I will get 32. So to get the equivalent fraction, I need to multiply 8 also by 8 and I will get 64. So 4 by 8 and 32 by 64 are equivalent fractions or fractions which have same value. Let's see another example. 3 by 4. If I multiply the numerator by 3 and denominator by 4, it will not be an equivalent fraction. Why? Because now the value of the fraction changes. If I am multiplying the numerator by 3, I should multiply the denominator also by 3 to get equivalent fraction. Now 3 by 4 is equal to 9 by 12. Similar way, if I have a fraction 8 by 12, if I am dividing numerator by 2, I can't divide denominator by 3 or by another number. It will not give me an equivalent fraction. I have to divide numerator and denominator both by 2 and then I will get an equivalent fraction. So 8 by 12 is equal to 4 by 6. So equivalent fractions are the fractions that are same in value, that are equal in value. How do we get equivalent fractions? By multiplying the numerator and denominator by the same number. Now suppose I have a fraction 1 by 2. What if I add same number to the numerator and to the denominator? The value of the fraction changes. 1 by 2 is not equal to 2 by 3. So by adding same number to the numerator and denominator or by subtracting the same number from numerator and denominator, we don't get equivalent fractions. Now let's understand equivalent fraction by visualization. I have a fraction 1 by 2. I know it is equivalent to 2 by 4. I multiplied numerator and denominator by the same number 2. Now again I multiplied the numerator and denominator of 1 by 2 by 3. So all these three fractions are equivalent fractions. Now let's see by visualizing it. Suppose I have a big pie and two friends come A and B. I have to divide this pie into two equal parts so that I can divide it between A and B. So suppose this and this part are equal. A will get this and B will get this. So how much did A got? So how much did A get? A got 1 by 2. A got one part out of the two parts. So A got 1 by 2. Similarly, B also got 1 by 2. Now suppose instead of dividing this pie in two equal halves, I would have divided it into 4 parts. Again, I had to divide between A and B. How many parts B would have got? 2. So B got these 2 parts and A got these 2 parts. So A got 2 by 4, 2 parts out of 4 equal parts, and B also got 2 parts out of 4 equal parts. The total size for B in both the cases remain the same. In both the cases, B is getting the similar quantity of pie, only the number of pieces have changed. Here B got one big piece, here B has got 2 smaller pieces which together are equivalent to the one big piece. So that is why 1 by 2 is equal to 2 by 4. Now suppose instead of dividing into 4 parts, I would have divided it into 6 equal parts. Now how I would have divided between A and B? Obviously 3 parts for B and these 3 parts for A. So in this case, A got 3 pieces out of 6 pieces. A got 3 by 6 of the pie and B also got 3 by 6 of the pie. 3 pieces out of the total 6 pieces. But again, if you see, the total size of the 3 pieces is same as the total size of 2 pieces here, is same as the size of 1 piece here. So 1 by 2, 2 by 4 and 3 by 6 are equivalent fractions. So if we multiply the numerator and denominator by the same number, we get equivalent fraction. Or if we divide the numerator and denominator by the same number, like in this case 2, we will get the same or equivalent fraction. Now let's see one more example. Suppose I have a chocolate and I have to take 1 by 5 of this chocolate. What would I do? I will divide this chocolate in 5 equal pieces and I will take the one part. So this one part is 1 by 5. Suppose I have to take 2 by 10. Now I know 1 by 5 and 2 by 10 are equivalent fractions, as I have got 2 by 10 by multiplying numerator and denominator by the same number 2. So in this case, I will divide the chocolate in 10 equal parts, as 10 is the denominator. So I have to divide the chocolate in 10 equal parts and I have to take 2 parts. So I took 2 parts. See, again the total size is same. Now let's check the same thing for the addition and subtraction. Suppose I have a number 1 by 2. How much will I get? I will divide this pie in 2 equal parts and I will get 1 part. Now I will add 1 to the numerator and 1 to the denominator. Now I have to divide this pie in 3 equal parts. So how many parts I am getting now? I am getting 2 parts. Can you see? Here I have got a bigger share than the previous case. So adding the same number to the numerator and denominator doesn't give me equivalent fraction. Addition and subtraction of same number to the numerator and denominator will not yield equivalent fraction. 2 by 3 and I subtract 1 from the numerator and 1 from the denominator, what will I get? 1 by 2, but we have already seen that the total quantity or the total share, the actual share which the person is getting has changed from the first case to the second case. So addition and subtraction of the same number to the numerator and denominator doesn't yield the equivalent fraction. But yes, if I multiply the numerator and denominator with the same number or divide the numerator and denominator by the same number, we will get equivalent fractions. Now let's see representation of equivalent fractions on number lines. So I have drawn the number line, 0 at the center, 1 on the right, minus 1 left, arrows showing that the line can go in both the directions indefinitely. So if I have to show 1 by 2, I will divide 0 to 1 in 2 equal parts, and this is the first part, 1 by 2. So this is the representation of 1 by 2. Now I have to represent 2 by 4. I will divide 0 to 1 in 4 equal parts, and I have to take the 2 parts. So 1 part, 2 part. So this is 2 by 4. Now I have to divide the number line in 6 equal parts. So now I will divide it into 6 equal parts. This is the first part, second part, third part, fourth part, fifth part, and sixth part. So I have to take 3 parts. 1, 2, 3. So the same number 1, 2, 3. So the same point will represent 3 by 6. So we can see 1 by 2, 2 by 4 and 3 by 6 are equivalent fractions. The only difference is that in 1 by 2 you are getting 1 piece, but that is a bigger piece. 2 by 4 you are getting 2 pieces, but there are smaller pieces. But the total size is same as the previous case. And 3 by 6 you are getting 3 pieces, but again the total size of 3 pieces is same as the total size of 2 pieces here, is same as the size of 1 piece here. So the value of the fraction has not changed. So equivalent fractions point to the same location on the number line. Next topic is fraction simplification. Fraction simplification means reducing the fractions to their lowest form. So what does it mean? So suppose I have a fraction 4 by 6 and I know that 4 and 6 have a common factor 2. So even if I divide by 2, the numerator and denominator, the value will not change. So 4 by 6 is equivalent to 2 by 3. Now 2 and 3, they don't have any common factor. 2 and 3 are co-prime numbers. Now I don't have any other number which can divide both 2 and 3. So this is the simplest form or the lowest form. So a fraction is said to be in the simplest form when the numerator or the denominator don't have a common factor other than 1, or when the numerator and denominator are co-prime to each other. So to get a fraction in the simplest form or in the lowest form, we need to divide the numerator and denominator by their greatest common divisor or by the highest common factor. Both are same thing. Let's understand it through an example. Suppose I have a fraction 16 by 24. I have to bring it to the simplest form or the lowest form. I will look for the highest common factor of 16 and 24. And we know the highest common factor for 16 and 24 is 8. So I will divide 16 and 24 by 8. We know that when we divide the numerator and denominator by the same number, the value of the fraction does not change. So we got 2 by 3. So 16 by 24 is equivalent to 2 by 3. 2 and 3 don't have any common factor other than 1. They are co-prime numbers. So this is a fraction in the simplest form. Let's see few more examples. 15 by 25. Is it in its simplest form? You are right. It's not in its simplest form as 15 and 25 have the common factor 5. So let's divide 15 and 25 by their highest common factor, which is 5. So when I divide 15 and 25 by their highest common factor, I will get 3 by 5. Now 3 and 5 don't have any common factor other than 1. So it is in the simplest form. Let's see another example. 1 by 7. So 1 by 7 already it's in the simplest form as I don't have any common factor other than 1. Let's take another example. 36 by 42. We know the numerator and denominator, they have a common factor 6. So I will divide the numerator and denominator by their highest common factor and I will get 7. 6 by 7. Now 6 by 7 is in the simplest form as 6 and 7 don't have any common factors other than 1. If I don't divide by the highest common factor and just divide by some other factor, I will not get the fraction in the simplest form. I will get a fraction which may need further simplification. So in this case 1214 further needs to be simplified. I can divide the numerator and denominator by 2. They have a common factor 2 and eventually I will get 6 by 7. So to directly get the fraction in the simplest form, you can divide the numerator and denominator by their highest common factor. Or you can do in these steps till you get the fraction which is in the simplest form. Now let's look at comparison of the fractions. When the fractions have the same denominator, it is very easy to compare. You can simply compare the numerators. Now in this case, both the denominators are same. 2 is greater than 1, so you can put 2 by 8 is greater than 1 by 8. In this case, the person is getting 2 pieces out of 8 pieces. In this case, the person is getting 1 piece out of the 8 pieces. 3 by 7, 6 by 7. 6 by 7 is greater than 3. So when denominators are same, you simply need to compare the numerators. 16 by 32. 17 by 32, 101 by 78, 107 by 78. So when the denominators are same, you simply need to compare the numerator. And why so? Because when the denominator is same, we know the size of the pieces or the number of pieces are same. And now there is a comparison only between the count of the pieces. So obviously, higher the numerator, higher the count of pieces the person is getting. Now what about the fractions when they have different denominators? So suppose I have a fraction 2 by 3 and 3 by 4. How do I compare these two fractions? Which one is greater, which one is smaller? I need to bring the denominators same. So I can take a common multiple of 3 and 4, or I can take their least common multiple LCM, or I can take any common multiple of the denominators. Suppose I took 12. So to get the 12, I had to multiply 3 by 4. So to get the equivalent fraction, we need to multiply the numerator also by the same number. Since I multiplied 3 by 4, I also need to multiply 2 by 4. So 2 by 3 change to 8 by 12 and 3 by 4 will change to 9 by 12. And now we can easily compare. So to compare the fractions with different denominators, we need to bring the denominators same and then we need to find the equivalent fraction. So suppose I have a fraction 1 by 7, 2 by 5. I will bring the denominator same. So I will take the LCM 35, least common multiple. I can take any other common multiple of 7 and 5. So I will change it to a fraction whose denominator is 35. So obviously the denominator needs to be multiplied by 5 to get 35. So I need to multiply numerator also by the same number. So I got 5 by 35. 2 by 5 again. I will have to multiply 5 with 7 to get the denominator 35. So I need to multiply the numerator also by the same number to get the equivalent fraction or to get the fraction so that value doesn't change. Now you can easily compare 5 by 35 and 14 by 35. 14 is greater than 5. A quick trick to compare the two fractions, 1 by 7, 3 by 9. Multiply 1 by 9, 1 into 9 is 9 and write it this side. Multiply 3 by 7, 3 7 21, write it this side. Now which number is bigger, 9 or 21? Obviously 21. So this fraction is bigger than this fraction. You tell me in the comment section, how did we arrive at this trick? Let's see another example. 16 by 32, 15 by 17. Now let's compare these two fractions using the trick. So I will multiply 16 with the denominator of the other fraction and I will write 16 into 17 this side. I will multiply 15 with the denominator of the other fraction and I will write 15 into 32 this side. Now 16 into 17 is equal to 272 and 15 into 32 is equal to 480. So 480 is greater than 272. So 15 by 17 is greater than 16 by 32. Now suppose if I have more than two fractions, what do? I have to compare 1 by 2, 4 by 5 and 2 by 3. I bring the denominator same so that I know that the size of the piece is same. So I will look for the LCM, least common multiple of 2, 5, 3. So 30. So I have to bring the denominator to 30. To bring the denominator to 30 for this fraction, I need to multiply the denominator by 15. And to get the fraction in equal value, I need to multiply the numerator also by 15. So 1 by 2 will transform to 15 by 30. Similar way, 4 by 5, I need to multiply the numerator and denominator by 6. So that I get the denominator 30 and I get the equivalent fraction. Here I need to multiply numerator and denominator by 10 so that I get denominator 30 and I get the equivalent fraction. So to get equivalent fraction or the fraction same in value, the numerator and denominator needs to be multiplied by the same number. Now all these fractions have the same denominator. Now we can compare the numerators. Now we know the 15 is the smallest. So 1 by 2 is the smallest. Then comes the 20. So 2 by 3. And then comes the 24. 4 by 5. So this is the increasing order. Or if I have to put it in the decreasing order, this is the decreasing order. So for increasing and decreasing order, I need to bring the denominator same. Let's take another quick example. In this case, again, I need to bring the denominator same. So I will look for a common multiple of 375 or I can look for the LCM to make the calculations easier. So it will be 105. Now to bring the denominator 105 for 1 by 3, I need to multiply the numerator and denominator by 35. So 1 by 3 will be transformed to 35. For 2 by 7, I need to multiply the numerator and denominator by 15. For 3 by 5, I need to multiply the numerator and denominator by 21 to get the denominator 105 and to get an equivalent fraction. We cannot only multiply the denominator by a number as it will change the value of the fraction. We need to multiply the numerator also by the same number. Now we can easily compare the numerators as the denominator is same. So the least number is this one, 2 by 7. Then this one, which is 1 by 3. And then this one, which is 3 by 5. So this is the increasing order. If I have to put in the decreasing order, this will be the decreasing order. So to compare the fractions, you have to bring the denominator same. In the efforts to bring the denominator same, don't forget to change the numerator also. If you're multiplying the denominator by a number, you need to multiply the numerator also by the same number so that value of the fraction does not change. Just a quick summary, equivalent fractions are the fractions which have same value only representation is different. Simplification is bringing the fraction to the lowest terms or simplest terms such that the numerator and denominator don't have a common factor other than 1, or numerator and denominator are co-prime to each other. When we have to compare the two fractions or multiple fractions, we need to bring the denominator same. Once we have brought the denominator same, we can simply compare the numerator ignoring the denominator. If the denominators are different for two fractions, we can follow the cross multiplication trick. We can multiply the numerator by the denominator of the other fraction and we can compare the product. When we have to compare the multiple fractions, again we have to bring the denominator same, and in an effort to bring the denominator same, we should not forget to transform the numerator accordingly. That's it for today. Hope you enjoyed the video. If you like the video, please like, share and subscribe. I will be coming up with more videos on fractions. Thank you.